Hello, everyone. We are extremely happy to be with you today, Tarek and I, in this one another session to talk about technical things, about what matters for us, cloud architects, platform engineers, DevOps people, and excited to be digging deeper, actually, on the technical side of things. Yeah, I know that some people are enjoying AWS reInvent, so we are adding more technical content today for those who are with us. So let's get started. Let me share my screen here and let's. All right. Just a brief introduction about us, who we are. I'm Shafiq, the founder of Brainboard, and I'm actually an engineer. I've been building cloud infrastructures for 17 years now, and I'm with Tarek today.
Hello, everyone. I am Tarek, and I'm cloud architect at Brainboard. I'm very happy to be with you today.
Yes, we're excited to be with you today. We both work at Brainboard. Just quickly, what Brainboard is. It's a solution that allows you, cloud architects, platform engineers, DevOps people, technical managers, and even developers to visually design and manage cloud infrastructures. This means that you have the possibility to build cloud infrastructure from scratch, day one, and also deploy it, allow anyone to contribute and do a lot of things about the infrastructure and maintain the complete lifecycle and infrastructure. We'll be using Brainboard today for our session, so you will have a chance to see how it looks like. All right, so today we will be talking about what is called the producer-consumer model, especially when you build cloud infrastructures within a company where you have different teams and different people, different needs, different requests for the cloud infrastructure, what this producer-consumer means. And then we will be digging deeper in terms of like what are the implementations and the type of implementation. Probably you are doing some of it, maybe not completely, or maybe you are fully mature on it. But the goal here is to go deeper. We will be also talking about the maintenance. All right, it's not. I mean, it's beautiful to implement things and put them into work, but it's great to maintain them and be able to allow everyone to build on top of what you have built. We will be seeing also the role of the CI/CD, and of course, the goal here is to take questions. So feel free to drop in the chat any questions you have, any comment. So we'd love to see the community interacting and asking us questions.
And I have a first question for you, Shafiq.
Yes.
What is the producer-consumer model and why people speak about it?
Yes, this is first thing first, exactly what the producer-consumer means. I have a slide, actually. Just to warn you, I just have 3 slides. So this is the second slide that I have, and they have 2 more, and that's it. So the producer-consumer, and in some companies, it's called a self-serve. Some of them, I met a customer recently, and they call it like platform as a ticket. So you want the entire platform to just be provisioned just by creating a simple ticket in a ticketing system. So the producer-consumer means that there are some people, one or many, that creates the infrastructure. It could be platform engineers, cloud architects, DevOps people. These people care about the infrastructure. They design the infrastructure, create it, and deploy it. And the consumers are those who are not supposed to build or maintaining the cloud infrastructure. They just need to consume it as it is, to use it as it is. For example, I'm a developer or product team, and I want cloud infrastructure to deploy my application. So maybe I don't need to worry about the cloud infrastructure. I just need it to exist to be able to deploy my application. Of course, when we talk about the cloud native, which means the architecture of the application is like 99% the architecture of the infrastructure. You may argue and you may say like, okay, I mean, even developers need to maintain the cloud infrastructure. This is part of their accountability, and this is part of their way of doing things. But what we see in the enterprises and companies that the cloud is much more complex, and it needs a dedicated team or teams, especially when you talk about security, FinOps, best practices, standardization, and so on. So usually there is a separation between those who build cloud infrastructure and those who consume it. So that's the explanation of the definition of the producer-consumer is as simple as this: one that builds a service, and another one that consumes it.
And about this as well, how do you believe that producer-consumer model improve the process of infrastructure provisioning compared to the traditional model that we all know?
This is a very good question. It's an excellent question, actually, because, I mean, we are talking about, it looks like we're talking about a new concept, and we need to understand what exists and how it looks like and why it's different. So before this, let's analyze how the life of an engineer will look like, someone who is building cloud infrastructure. So for now, I will be using Brainboard because it's I have everything in it, so I will be able to visually show you what I'm talking about. All right, so I switch into Brainboard here. And let's assume, like, I want to build cloud infrastructure, like I have a request to build a function app or web app, or I choose Azure. I can switch into AWS or use any other cloud provider. The cloud provider really doesn't matter. What matters is really what you can do with it. And you can do this almost the same thing with all cloud providers. So let's start, for example, I want to the function app. So here, I'm going to use a variable for my location. All right. And inside my location, I'm going to add a resource group. I'm going to build something simple here just to show you like how I put myself in the shoes of the producer. So I'm going to create a cloud infrastructure, and then later I'm going to put my shoes in the consumer and see how the life will look like. This is called it producer consumer. All right. Inside my resource group, I'm going to put my function up and just here add the function up. The function add need service plan. So I'm going to take that service plan from here and call it var.name. The OS type, just pick Linux. And the SQ, I'm going to pick the P1. The P1. I'm going to take V2. All right. And I'm going to add the storage account. Something really basic, like for the storage account, I'm going to use the LRS, and the account here, I'm going to pick the standard, and the name, I'm going to give it var.name. I want to use the same name for all of them. And for the function app, I'm going to choose the service plan here. Since I'm looking for the ID, I'm going to pick the ID. The name, I'm going to call it user variable. And the key, storage account key, I'm going to take this one. And for the storage account name, I'm going to take the storage account and add the name. All right, so this is my, let's say, simple infrastructure. Let's make it smaller, centralize it. All right. And I have a variable that is called name here, Brainboard. And for the location, I'm going to use a default one, East US. Okay. So back to your question, Tarek, is about, okay, how is this different from the legacy world? So in the legacy world, I have this infrastructure, and usually I just have the Terraform code here with the variables that I put here. And every time someone asks me about, okay, I need the same thing, I need to deploy, like the first developer asked me about this infrastructure, I build it, I'm happy, it's good. 1 week later, a few days later, another one will ask about the exact same thing. So what I do usually, I can go to the repo that for the first scenario, for the first infrastructure, and clone the repo, rename it, and change the variables and provision the infrastructure. Or I can have like another way to maybe convert this infrastructure into this repo into a template that I will use it later. So the legacy word is that you build your use case when you need it. So there is no way of like, we don't usually think about building a plan or building a library of all the use cases that we may have, or we document them as they go, as they come, in a way that we are building a process. And so that's extremely important. So because one of the challenges, if I have this infrastructure, I just clone the repo that has been deployed, is maybe the infrastructure has been changed a lot in a way that is too far from the initial use case, which means if I clone it, I need to clean it. If I use variables, so I need to reanalyze the variables, like what should be, what should stay, what I need to modify. So I need to review a lot of things to make it work. So that's what's the difference of producer-consumer model versus the legacy one, is that you are, with full awareness, building a system that allows you to build patterns or build a self-serve module that anyone, in a way that anyone can autonomously use your work. And this has a great advantage, especially I mean, when working with different teams, because the cloud architects or DevOps people, platform engineers, will no longer be the bottleneck. Because, I mean, this is the nature of things. If you have a team that manages the cloud infrastructure needs for all their teams, they become the bottleneck by definition. So the goal here is to remove this bottleneck and allow anyone to go full speed based on their use case and their way of doing things. So that's more or less the producer-consumer. And actually, yes, to like deepen what I'm talking about, let's just have a look of this slide. So the producer, when they need to build a cloud infrastructure, I just built one within Brainboard. So it's this is more or less what I need to do, or what you need to do. First, you need to design your cloud infrastructure, or maybe you can say, okay, we do not design, we just write the Terraform code. That's fine, totally fine. You can say, okay, I'm going to create the code for infrastructure. And this code, I'm going to test it. I'm going to review it, validate it. I'm going to go through all these steps to make sure that the code is working. And I put in this code and this infrastructure all the best practices and the naming conventions and the security and maturity that we have internally, and build a use case that anyone from the consumer side, they can use it as it is, or combine it with a different pre-existing use cases. So the module that we are talking about is that the link between the producer and consumer should go within a platform that allows them to both work in an efficient way, because the producer needs also to maintain the infrastructure, is not find and forget, and the consumer needs to go full speed. And if there is any use case that is not created yet, they can request it. So that's Tarek, to answer your question about how this is different from the legacy work.
Perfect. I have another one for you. The one that I have is, can you elaborate on the challenges that could exist about producer and consumer, about provisioning cloud resources for multiple teams multiple times?
Yes, this is a very good one, because that's true. I just showed you producer and consumer. It could be like one person, and the consumer could be another person. But when you work within a company, you probably have different teams, and the challenge is not just that you build it for a specific use case, but you build it for multiple people. So the challenges, that are related to this are also related to different points. The first one is the challenge of this one is the learning curve. So, for example, here, if I am a consumer, if I'm the consumer, I have a lot of things to worry about and to learn if I have to do it myself. And the goal here is to be able to not spend time and energy on things that are not actually my main area of focus, but just to use the knowledge of my team as well. This and it's not about the learning curve is not about when to build, but it's also about maintaining, keeping things up to date. And the other one, also one of the challenges, actually, this is like an implementation challenge, is that what's the format of the implementation? Which means, for example, here, if I go back to Brainboard, I have this infrastructure. So in which format I'm going to put this producer-consumer model that it makes sense for my organization and for my people? Because, the problem in the industry is people, process, and tools. So I talked about, for example, the first use case, the legacy word. I just clone the existing repo and create the infrastructure. But also, I can create a template. But the problem with the templates is, okay, who maintains the templates? Should I need documentation about it and how to use it? I need to make sure that the consumer is able to find the template and use it properly, and so on. So these are the challenges for the producer-consumer. And one of the challenges as well is the platform. We were talking about here this platform. If I use different tools and fragmented tools to build and manage the cloud infrastructure, by definition, I'm creating more complexity than simplifying things for the users. So that's why it's extremely important to have this, like the platform concept, central to this model. If you want to build a self-serve module, you need to federate and centralize everything in the same platform that anyone can find which is which, and they can go full speed based on their use cases.
Also, when people speak about the producer-consumer model, they also think about the CI/CD. What is the relationship between the CI/CD and this model that you describe here?
Yes, this is a very good one as well, because again, when we talk about the cloud infrastructure, and especially the IaC infrastructure as code, we talk about automation. And it just means automation. IaC means CI/CD means pipelines. Let me show you something more interesting. So let's first analyze the workflow of the producer. Okay, how we build these steps that I mentioned here, how it works. So the infrastructure workflow, I first start with the design, and we can say, okay, maybe you don't need the design, but at some point you need to understand to visually see what you have. And then I can say, okay, I'm going to write the Terraform code for this infrastructure. Most of us write Terraform code, but it's valid for any language you pick. It's valid for Pulumi, it's valid for Ansible, it's valid for any language you pick. Then I'm going to test this code. And usually, like, I'm going to test for security, check if the costs are within the budget, send some notification to different people, and maybe I want to integrate with an external system to be able to execute the actions that I want to do. All right, and these are all CI/CD and tests. Once this is done, once the test is done, so here I want to integrate the feedback from the test into either the design or the code. This is what is called shift left. So I'm going to reduce the feedback loop. As the shorter the loop is, the faster I can build the cloud infrastructure, and the faster I can deliver it, and the faster those who depend on me can go as well. All right. So once I integrate all this knowledge, I'm going to review and validate and probably approve if we have an approval system. If you have an approval system within your company, once it's approved, it's provisioned. All right. Once the infrastructure is provisioned, it's not the end of story actually, because you have a lot of things to do once the infrastructure is provisioned. So what the most important things are how you can scale what you do, and how you can handle multiple environments, and how you can have strategy around this. So here I just listed all the things that you can do once the infrastructure is provisioned, and you can have a disaster recovery strategy. You can put like drift detection to be able to detect if anything happens outside of the source of truth. You can integrate with different systems. You can build your own catalog. You can document it. So a lot of things that you can do once the infrastructure is built. So when you talk about the CI/CD, the CI/CD is just this part here, like maybe from the test to the provision. It's not the complete picture. It's extremely important. Automation, it's extremely important, but it's part of the picture and not the global picture. So when you build the producer-consumer module, you need to be aware of this, and you need to think and design it in this way that, okay, I have the CI/CD, but what are the different aspects that do not fit within the CI/CD that I need to care about to make my process work, like to allow anyone really to be autonomous and to really create a self-serve module. Because we have seen it with the CI/CD. I mean, if you just give the team the repo, they will clone it. If there is anything, they will get back to you, or they struggle. So that's why it is extremely important to think about the big picture, a holistic view of the picture, and not just a part of it. So that's when we talk about trying to position where the CI/CD fits in the entire process.
And this is very interesting, because I was going to ask you the question of the advantages of such workflow, especially when you are speaking about a no-code provisioning workflow. So I think it's very interesting what you said.
Yeah, and also one of the things that I have in mind. So I switch into Brainboard to really depict what I'm thinking about, about this complete workflow. Here, so when I build a cloud infrastructure, the first thing is that, okay, I want to make sure that what I'm building is secure. Here, I can use the CI/CD. I can go here, and let's, all right, so here, call it producer consumer workflow. And first, I start by, let's say, validating the code. I'm going to take your code validation. All right. So once my code, I'm sure that my code is valid, I'm going to build some security checks. For example, security check 1. And by the way, these are open source plugins, are not Brainboard software, not open source. We took most use open source tools, and we are integrating them into Brainboard in a way that it's easier for you just to use it in a self-serve module, and you do not need to worry about maintenance. All right, I'm going to combine it with another one, security check 2. I want to add maybe some kind of estimation of the infrastructure, the cost of the infrastructure, to bring FinOps awareness for anyone who is about to use this infrastructure. I can take the infra cost here, and for the infra cost, I can take my API key to use it within infra cost here to see the estimation of the cost. All right. Okay, I'm going to put it here. Okay. Once this checks are done, I can, for example, review or send an email or Teams notification or Slack to anyone within the team, like, for example, to cloud architects. At brainboard.co, like, and ask them, like, please review the infrastructure. And the goal here is to really work in a collaborative way, and not just me, like in my corner trying to build my cloud infrastructure and pushing it to production. Is really to take advantage of the team and the awareness, the maturity of all the people around me to build a cloud infrastructure. And then I can say, okay, once this is good, I'm not going to deploy it, because this is just to make sure that what I'm building is fine. And now I can trigger the pipeline. And the goal here, as I showed you, is to reduce the feedback loop. This is part of my workflow. I'm going to see what are the output of the execution. And if there is anything that I need to fix, I will fix it into the architecture. So here it's successful. I can see that the execution is good. I have a warning that the function app is deprecated. I have to use either Linux or Windows function. That's fine. I can take this consideration. In terms of the costs, I can see that this one will cost us $73. And in terms of security, I can see that I have two critical issues, even if the infrastructure is simple. And I can say, okay, the TLS version for the storage account is insecure. And for, again, for the function app, it doesn't have HTTPS enforced, enabled by default. So, okay, I have this feedback loop, and I can go now into the design. I can search here for HTTPS. I can put HTTPS true. And for the storage account, I have TLS, and I'm going to choose the TLS version. The minimum is 1.2. All right. So once I build this, I can say, all right, this infrastructure has been, now I'm going to say it's approved. So it has been approved, tested, and everything works as expected. Now I can turn it into a template that anyone can use it off the shelf. And I see that you are connected, Tarek, with me in this infrastructure. So it's a great way that a great way to build cloud infrastructure collaboratively. Maybe you need to add something, because I know, for example, here we need the private endpoints. We need Kubernetes cluster. Yeah, I see that you added Kubernetes cluster, but we can say, I need private endpoints. I need some other components so that we can work together to complete this infrastructure. All right. Yeah, perfect. I see that you are adding the, I see that the code is generated as well. All right. So now I take this infrastructure, complete infrastructure, and I will say, all right, now I'm going to put this cloud infrastructure, to convert this cloud infrastructure into a template. All right, so here I'm going to call it template. And the goal, and that's the importance of the platform, is that I have a central piece that allows me to manage my process in an efficient way. What does it mean? It means that like I publish my work in the same platform that someone else can use it. So now I put myself in the shoes of the consumer. Let's say I'm a consumer. So how my life will look like, I can go here, let's pick another project, for example, another environment. I do not have any architecture. And I can go to the templates catalog and search for producer consumer. This is the architecture. Actually, the architecture, you can write any documentation about the architecture. It's highly recommended to write documentation. I will show you how it looks like. For example, here, if I pick this architecture, yeah, you can write a complete documentation about, if you want to explain to the consumer, what is it, this architecture, what are different components, what are the requirements. If you want to add the maintainers list or people to reach out when there is problem, you can do it this way. So here, I go back to this architecture, and now I'm going to consume this architecture. So my life is much more easier when I have the full context. And I see that my colleagues is working with me as well, so they can help me to do anything. So here, I can visually understand that, okay, this is the architecture that I need to deploy. If I want to go deeper into the code, I can see that, okay, this is the configuration. Or if I'm just a consumer, I don't need to worry about the cloud infrastructure, about the code itself. I cannot worry about the code because this architecture has been approved and put into the catalog only once it is approved. So this is one of the ways to build, this producer-consumer model. We have seen also in the legacy world that you have three ways to build this model. Either use a template, but again, the platform is important for the template to work, or use the modules, the Terraform modules, and this is pretty popular. Like everyone is using modules now. The downside of the modules is that it's an abstract. So if you just give a module to the user, to the end user, they don't know what's inside the module. Sometimes it's good. They don't need to worry about what's inside as it does what it's supposed to do. That's totally fine. But sometimes the users need to understand what's inside the modules. And also another point about the modules is that if you give multiple modules to the user, they need to understand how they combine the modules with each other to build their cloud infrastructure. And the third way, and this is what we have talked about before, is the third way is I clone an existing environment. Like this infrastructure has been deployed. What I do here, I just go to the I just here to the clone, and I want this clone in a QA environment. So I just take this infrastructure and clone it, and let's say, okay, I want to consume the same system, the same infrastructure that I have in production in a different environment.
And this is perfect, because I was going to ask you the question between the difference between the modules and the templates. So in one sentence, can you please summarize it?
Oh, yes. This is very important. And this is actually extremely important. Yes. So the templates are meant to be like the starting point of the infrastructure. So for example, here I have a complete use case that I put it into a template that when I have to deploy, I just pick it off the shelf. The modules are supposed to manage the life cycle of the resource. For example, here I have Terraform module, Cosmos DB, for example. Okay, let me show you the code here. If I put Cosmos DB here, actually I have the module block, and I have the version of this module. So for example, if the maintainer of the module changes the module and integrate more security or change the resources, upgrade it, or whatever the change they do, I am able to get these changes every time they happen, and I can refresh it. So for example, here, if I specify any random version, I can say, okay, I want to fetch this specific version. It doesn't exist, of course, so that's why you have the error here, that it doesn't exist, but that's how it works, so that I can target the version or keep it the latest. So here, when I keep the latest, I just use it as it is. This is like in terms of lifecycle. With the modules, you can manage the lifecycle of the, I'm sorry, here in the modules, you can manage the lifecycle of the resources and the complete resources as a stack within the module. The template are supposed to be a starting point. Like I have a use case, fast, I can build it. What is important to notice that you can build the templates with the modules. And this is much more powerful because it's a starting point that stays up to date whatever and whenever you make a change on the infrastructure. This is extremely important. The other thing about the modules and the templates is the level of configuration that you give to the users. So, and this is here, I'm going to talk about the variables and locals. This is specific to Terraform. Since we are based on Terraform, that's extremely important to explain. You have, the variables in Terraform, and specifically in the modules. This is something that the user can configure when you give them the module to use. For example, here, all right, these variables, the required one and optional, these are all Terraform variables that has been created in the module that I can change. Versus the locals that are created here, these locals are not visible to the user to change. So when you build a module, you can hide some details. For example, you have some naming conventions that you want to build automatically or to calculate automatically when the user puts some inputs like the environment name, the application type or application name or whatever, and you can combine these variables to create the naming convention. And you want to hide it to the user, that they don't have to set the name. You force them to have naming conventions. The module is much more powerful. In the templates, actually, you give them both control over the variables and the locals. Because when I build a local here, let's call it RG name, and in the RG name, I'm going to combine it. I'm going to combine multiple ones. Like let's put here var dot prefix with another variable var dot app name dash rg, for example. So, all right, I need to create the variables prefix and app name. So here I'm going to create prefix, which is a string, and call it bb. And all right. And here app name, which is also a string, and let's call it, for example, prod consumer. Okay. So when I convert these architectures into when I convert this architecture into a template, actually the consumer has access to both the locals and the variables, so that they can understand what's the RG name. Let me change this one here. So for the name, I'm going to use local.rg name. So if the user comes here and the consumer comes here and sees that in the RG name I'm using a local, they have the possibility. So they first understand that the name is configurable, and the second, they have the possibility to see what the local is and how it is used in the variables. So that's the main difference between the templates and the modules. Again, just to recap, the templates is meant to be a starting point, and it gives to the user like an explicit diagram and all the components that are used for the infrastructure. The module is supposed to be an abstract, and an abstract from the resources, but also an abstract from the variables if you put them in the locals, and the module is supposed to manage the lifecycle. So the great combination is the great way to build a producer consumer module is to combine both modules with the templates. And this comes with the maturity, of course, of the team and those who are managing the cloud infrastructures, but also it comes with the use cases. I'm not a fan of building things just for building. I'm really like to build real use cases when they come and not like brainstorm about the future. Yeah, but that's the great combination when you have to deal with both of them.
And this is really interesting as well, because as a consumer, all I care about is actually to have a ready-to-use infrastructure. So if I understand it well, based on your scenario right now, is that I can use modules, I can use templates, and it's already ready to use for me. I don't need to be a Terraform guru to be able to use your work and consume it, of course.
Actually, that's the goal of the producer consumer module here, is that, again, into the slide before, is that the consumer is supposed to use infrastructure as it is, or at max combine different pieces together to be able to build a cloud infrastructure, but they stay as consumers. And the definition of a consumer is like exactly as this slide. When you have when you order food, you don't need to worry about you don't need to be chef to order food. You need to maybe sometimes to carry about and to worry or care about the ingredients, like I want to eat healthy, I want to eat organic, or I want to eat whatever I want to eat. You can inspect and see, but you don't need to be a chef. That's the role here. And the consumer they're not supposed to go through all this stack to be able to build a cloud infrastructure. So that's why, again, the platform is important. I'm using Brainboard, but it works as well for any other platform. And even if you are doing it manually, building manually your own producer consumer module with your own Terraform files and your own CI/CD and your own different tools, it works. Brainboard is just a way to consolidate all these tools, but it's the same principle. And the role here is that to lower either the learning curve for the users or the consumption barrier, so that I don't need to be, as you said, I don't need to be a Terraform guru to just use the work of the others. I need to just understand what the diagram is. Like if I'm a developer and I have to push to deploy my application, for example, on the function app or whatever I want on Kubernetes cluster, at least I need to know that it will be deployed on Kubernetes. And when I look at it, I can understand, like, okay, I have the networking, I have, for example, the private endpoints here. It's supposed to be inside a VNet, inside subnet, inside a VNet. If I use key vault, I can see which key vault I'm using, how it's connected to my application. If I have some secrets, I can see how the data flow between and how I consume the secrets. So that's the role of the model, is that the consumer needs to understand what matters for them. The consumers need to understand what matters for them. What matters for them is how they can use the cloud infrastructure, and how their application or what they care about works, and not like the details and maintain it every day. So this is like the life of the producer consumer module. And even in terms of like life cycle, the consumer doesn't need to care about the life cycle of the infrastructure. That's extremely important. So all they care about is that the application is up to date and keeps running as expected. So, yeah.
And I have the feeling that it's actually working when it's day one, but in the long run, how do you manage everything? How do you manage your infrastructure? How do you manage your templates? How do you scale your work?
This is an absolutely awesome question, because this is what we also say at Brainboard. Like, you have day one and day two, and this is valid for almost everything in life. You have day one, you do the things the first time, you deploy the infrastructure, you're happy, or you implement the producer consumer, and like the first use cases are happy. But okay, the day two, like the problems will start to come, and so there are here two important things. The first one is the life cycle of the maintenance. So which means if you are the producer of the infrastructure, you need to have a way to maintain this infrastructure and to keep it always accurate and always up to date, in a way that the consumer always have the right information. Again, that's why it's important that the platform is important. For just to give you an example here, if I search for producer consumer, okay. This is actually the templates. So Brainboard, when you use Brainboard, it creates a folder called the templates catalog, where when you publish them into the catalog here, you also have the way to maintain them in this catalog, which means, for example, here, I'm going to change. I can say, all right, let me change this here, like to show you really what the maintenance look like. Oops, sorry, what the maintenance look like. All right. I'm going to take subnet. All right, let's take subnet here. And give it a value as net 1. All right, and add a virtual network. All right, so virtual network. I know someone who is following us. I didn't add the VNet inside the subnet. I just drag and drop it. Brainboard actually understand that the subnet should go inside the VNet, so it draws everything for me automatically. Do not confuse our followers. So here I'm going to add the private endpoint, and for a location I'm going to use the variable that I had before. PE, or call it function up. File collection false, call it here function up. And for the resource ID, I'm going to use search for the function. Yes, this is what I'm looking for. All right. And here I call it sites. Okay. So I change the template. So now if, as a consumer, if I go back to, like, I put my myself in the shoes of the consumer, I'm going back to the production. I'm going to open the production, and I will take the templates of the producer consumer. So now if I clone it, I have the new version of the producer consumer. You see, I got the new version. So that's why it's extremely important, the lifecycle maintenance. And this is the way how you can scale it. And this is how the day two, like you keep the maintenance. And I can push it to the next level. I can say, okay, I go back to the templates here, where I have, okay, this is the templates. I can say, okay, I want even to add a documentation, because from now on, we want to explain everything. So here, put it producer consumer, section 1, for example, some information. Section 2, element 1, element 2, I'm sorry. And all right, that's enough. We can keep it like this. So I added documentation. So now if I go to the templates, it's automatically added to my template. So here, if I open the templates, the documentation is automatically populated. I don't need to do anything. So, and now the consumer has a bigger, like a more accurate way to interact with what I built. So that's why it's extremely important. The day 2 is that the possibility to bring changes in real time, that the consumers can follow you and can understand what you are doing, and whatever you want, you add later in terms of maybe you want to add more tests. Maybe you want to switch components to use the newer one because they are cheaper, or you have some a cost optimization that you want to inject, or some security audits that you are preparing for, and you want to inject all these security recommendation inside the design so the consumer can follow you. So that's extremely important. The second one, in terms of producer consumer model and how it may, the day 2 is important, is also for the management of the multi-environment. And this is extremely important. So here I go back to my use case, for example, this one, the latest one. As a consumer, sometimes I want to deploy the cloud infrastructure in multiple environments. And this is even the best practice. I don't just push into production, but I have dev, staging, QA, production, whatever. And it's extremely important to keep myself, to keep the environment close to each other and to remove any drift actually from the infrastructure. So for example here, let's go to the development. Let's pick the producer consumer. So here, if I'm in the development, I don't need to clone the infrastructure in production in QA or any other environment. I need, and let's, for example, let's rename this one, call it, for example, lifecycle. So I don't need to reinvent, I don't need to create an infrastructure or templates inside every environment. That's important to understand that I can create just a copy, or okay, I can move to production, and I can say, okay, I want Brainboard to synchronize all this environment for me. Again, I'm using Brainboard. You can do it on your own as well, and I think you can do it with TerGrunt. This is also what the teams are doing. It allows you to keep all the environments synchronized. This is natively integrated into Brainboard. So here, if I have my, so when I do this, all right, now I'm in production, and I can see all the replica of my infrastructure. So I do not need to do it manually for every environment and to clone the architecture and deploy it again. I just need to synchronize. What this means in terms of life cycle and continuous update, because the most important thing is the update and how I can manage the update, is that any change I do in one environment, I go back to my development, for example here, and I want to add in my development here, I want to add, for example, let's add a firewall. For example, I add a firewall here. Okay, and the firewall, and give it a name, var.firewall name. Okay, VNet and SQ tier, I'm going to take standard. All right. So here in the variables, since I'm in the development, I don't want to, okay, let's call it dev, for example. It will also work. One of the great examples as well is to To manage, for example, the SQs or the SQ name or the tier, you can say in dev, I want to use, for example, the basic, and in production, I want to use the premium because it's much more expensive. The basic is less expensive, and you can use it. You can have, you don't need to spend that much on the dev. All right, and now these infrastructure are synchronized, which means what I build here, I don't need to manually do it. It's a continuous update. So if I go back to the older architecture production, the change is there. I mean, the change is there. When I click on it, I have the configuration. The variable is created. All I have to do is to specify for this environment, what's the value of the variable. So here I'm going to call it production. So these are the most important thing when it comes to, yes, you can see it production here. Everything is the same, just the values of the variables are not the same. How we do it actually through the TF vars. So here in the TF vars, you have the production. And if I switch into development, I'm going to have here project name is development. So that's when we talk about the continuous update and the day 2 is like the 2 mechanisms. So the way to maintain the templates and also how to manage the multi-environment. The other point, which is the module, but the modules is that by definition, the lifecycle is managed because every time you push, if you keep, as far as you keep the version, the latest is automatically fetched. Even when you do the plan, Terraform will automatically fetch the latest version of the module and use it.
And here, Shafiq, we have some questions from the community. One of the questions is from Melin Saha. Great jobs. How are secrets and password managed?
Wow, this is a very good question. I love it, especially when it comes to security. So I'm going quickly to show you how it works. For example, here, let's make this bigger. And all right, I'm going to move this one here. And this one like that. All right. I missed it. All right, like this. So how the secret are managed? There are 2 types of secrets. So first, you can create a variable that is, and you can flag it as sensitive. For example, this name, let's assume it's sensitive. I can click on it sensitive. So when it is sensitive, it's still clear here, even like let's put it sensitive. So here it's not visible, but when you click on the variable, so here when you click on the variable, I can see it. And in the Terraform code as well is clear text. I do not advise you to do so. What I advise you to do is to use a key vault. So here, for example, either create a new key vault or reference an existing one. So here I can search for a key vault. For example, I can create a new key vault or use an existing one if I have an existing one, or I can switch from resource into data. All right. So here I switch and I can say, this is named like my existing key vault. And for my key vault, I'm going to use a secret. So I'm going to take the secret here, or I'm going to use an existing secret. If the secret exists, I can create a new one or reference an existing one. So I switch into data as well, and I can say, all right, this, it is in the key vault ID and the name my secret. All right, so now I have my key vault, which is a data, an existing key vault that has an existing secret, and now I can reference this existing secret in my Azure function, for example. For example, here, what I can do is I can put in the authentication, for example, client secret. Okay, for example, here for the secret, I'm going to search for the secret and use its value. So now I don't write anything clear. It's just a reference to an existing secret. So the Azure function used in the client secret, a secret that is an existing secret that is stored in the key vault. And my configuration here, you can see it's a reference to the value of the secret, and there is nothing stored in clear text. The only thing that you need to worry about is the Terraform state. So it's extremely important to have two things: to encrypt your Terraform state and to version it. In case anything happens, you can roll back. This is something that you can do as well in Brainboard. You can go here into the settings, and you can say, by default, if you use the default Brainboard backend, by default, we encrypt your secrets, and by default, the Terraform state, sorry, and by default, we version it. But you can use your own remote backend, either S3 or blob storage or GCS, or even if you have just an endpoint, HTTP endpoint, to use it as a remote backend is supported. So this is how the secrets work.
And then we have a question about the CI/CD, about OPA. So if you could show maybe how you could use it on Brainboard.
Oh, yeah. This is a good one. I was about to talk about the role of the CI/CD actually in the actual workflow. If I go back here to this slide, oops, sorry. As I said, the CI/CD is here, but it's crucial. It's extremely important. So here, the role of the CI/CD is in three parts. So you have before the release, during the release, and after the release. That's extremely important. So the OPA is before the release. So here, for example, let's take, let's take this template, CI/CD template. I can add an OPA here. For example, this is to check naming conventions, for example. So here in the you need to write the regos. You need to know how to write regos to be able to put them to use the OPA. The regos I can put here, like for example, rego 1. Actually, I have an example. I'm glad that the user asked. I can show you, for example, something in Azure. All right, so here I can say, this is how it looks like. The rego, I can say for any resource change, for any resource that has the CIDR blocks that is open to the internet, block it and show me the message that has 00 as allowed ingress. So to warn me that this is not like recommended. And I base my here, I'm gonna call it, package Brainboard. And here, I'm gonna base my decision on the deny. So if the deny happens, then this will stop. So that's it. It's here, and now I can trigger it. And this is also extremely important, the role of the CI/CD, because this is before I do the pull request. So I can even, like, before I deploy, before I do the pull request, before anything. And once these checks are good, then I can do, for example, a pull request to my repo, or I can deploy, or I can do anything. The second one, the role of the CI/CD, like before, during the deployment is through the approvals. So you can say, all right, all this is good. I'm going now to deploy. But I'm going to ask for an approval. Here, I'm going to ask for Tarek as an approver. So here, Tarek as an approver. So here, even me who created it, so let's call it deploy on approval. So if I trigger the pipeline, even me, I cannot approve it because this has to be approved only by Tarek. And this is during the approval. After, during the deployment, after the infrastructure is provisioned, it's extremely important to understand, to put some kind of monitoring. This is called the drift detection on the infrastructure. If I go back here, this is the design and build, and this is my source of truth. In Git or in Brainboard, whatever the source of truth, it doesn't matter as far as you have a single source of truth. Let's say this is my single source of truth, and I want to make sure that if anything happens to the infrastructure outside of my source of truth, that I will be warned. So if there is any drift happens, that I'm notified. This is something that you can build here as well. You can say, okay, I'm going to build a workflow for drift detection. And this workflow, I'm going to schedule it. Like it could be every day, every hour, let's call it, for example, every day at 7 a.m. in the morning, I'm going to do my checks as my routine. And if there is any failure or drift, send me an email. So here I'm going to put CB myself here. And if there is any problem, I will receive a notification. And then I will say, okay, detect the drift. So if there is any drift happening, I will be warned. So that's in the producer-consumer model. This is extremely important because it means that it's control but help at the same time. So you control what's happening on the infrastructure, but you help your users. But whenever they do something outside of the process, you have the possibility to actually know what they have done and fix it. And you can, you can fix it with them. This is the remediation part. I say, okay, guys, you change this thing from the portal, AWS portal, Azure portal. We don't need to do it. Let's integrate this configuration into the design, either in the templates or in the architecture, and make it part of the process instead of doing it manually. So it helps also bring awareness about the source of truth and how important it is to keep everything in the same platform. And I think we are over time. We talked about a lot of technical aspects about how to implement the producer-consumer model, how is important actually to have a platform that allows you to articulate and to bridge the gap between the two, between the producer and the consumer. What are the steps that is needed? And what I wanted to highlight as well is that building and maintaining the cloud infrastructure should be seen as a process, because the cloud infrastructure is not just a bunch of Terraform files or just an automation that it works automatically. There are people, process, and tools used and involved to build and maintain the cloud infrastructure. And you should see the bigger picture, not just being focused on one area. And the end goal is also to allow anyone to understand what's going on and contribute. So because if you have like the developers or product team or someone who is supposed to use the cloud infrastructure, coming back to you every time to ask questions and every time to interrupt you and ask you questions, you are not efficient in your work. I mean, you spend the majority of your time just manually automating things, but it's extremely important that you give them this possibility to be onboarded on the technical journey and understanding what's going on. So that's for today.
Thanks a lot, Shafiq.
Yes, we talked about, thanks a lot, Tarek, and thanks a lot for the community. There are a lot of things that we talked about, but it could be simple to implement. And the team is here, our Brainboard team. Outside of if you are using Brainboard or not, our goal is really to share technically like how things work and help technically. If you have any questions, reach out to us. Ping Tarek directly on LinkedIn. He is the most active guy of Brainboard on LinkedIn. Feel free to reach out. And hopefully we see you the next time with another technical session.
Perfect. Thanks a lot, everyone.
Thank you, Tarek. And thanks for the community. Enjoy, everyone.